day, everyone. Today, we're diving into the fundamental concepts of trigonometry. Our focus will be into the 3K learning objectives. First, using correct mathematical notation and terminology. Second, defining and drawing the unit circle while identifying the coordinates of special angles. And last, identifying the 6 trigonometric functions and their value limits based on their unit circle. So by the end of this discussion, you'll have a solid grasp of these concepts which are essential for mastering trigonometry. So let's begin. So our first topic, using correct mathematical notation and terminology. So mathematical notation is the universal language of mathematics. In trigonometry, precision in notation ensures clarity in problem solving and communication. So here are some key notations and terminologies. So first, angle representation. We use degrees and radians to measure angles. For example, 90 degrees equals pi over 2 radians. So second, trigonometric functions. This includes sine, cosine, tangent, cosecant, secant, and cotangent. Third, coordinate notation. Ordered pairs x and y represent points on the unit circle. And last, Greek letters. Greek symbols such as theta and commonly denote angles. And now, let's move on to defining and drawing the unit circle and identifying special angle coordinates. So the unit circle is a fundamental concept in trigonometry. It is a circle with a radius of 1 unit, centered at the origin. In the coordinate plane, the equation of the unit circle is x squared plus y squared equals 1. The unit circle is divided into 4 quadrants. Quadrant 1, here. Quadrant 1, 0 degrees to 90 degrees. Quadrant 2, Quadrant 2, 90 degrees to 180 degrees. Quadrant 3, 180 degrees to 270 degrees. Quadrant 4, 270 degrees to 360 degrees. So quadrant 1, both x and y values are positive. X and y values are positive. Quadrant 2, x is negative and y is positive. X is negative and y is positive. So quadrant 3, both x and y are negative. And last, quadrant 4, x is positive and y is negative. So starting point at 0 degrees. 0 degrees. At 0 degrees, the coordinate point is positive 1 and 0. This means cosine is 1 and sine is 0. Moving to 30 degrees. At 30 degrees or pi over 6 radians, the coordinate point is square root of positive 3 over 2 and positive 1 over 2. Moving to 45 degrees. At 45 degrees or pi over 4, pi over 4 radians, the coordinate is square root of positive 2 over 2 and square root of positive 2 over 2 again. Moving to 60 degrees. 60 degrees. At 60 degrees or pi over 3, pi over 3 radians, the coordinate is positive 1 over 2 and square root of positive 3 over 2. So next is 90 degrees. 90 degrees. At 90 degrees or pi over 2 radians, the coordinate is 0 and 1. So her cosine is 0 and sine is 1. Moving to 120 degrees. 120 degrees. At 120 degrees or 2 pi over 3 radians, the coordinate is negative 1 over 2 and square root of positive 3 over 2. So, moving to 135 degrees. At 135 degrees or 3 pi over 4 radians, the coordinate is negative square root of 2 over 2 and square root of positive 2 over 2. Moving to 150 degrees. At 150 degrees or 5 pi over 6 radians, the coordinate is negative square root of 3 over 2 and 1 positive 1 over 2. Moving to 180 degrees. At 180 degrees or pi radians. This is the pi radians. The coordinate is negative 1 and 0. This is the leftmost point of the unit circle. Moving to 210 degrees. At 210 degrees or 7 pi 7 pi over 6 radians. The coordinate is negative square root of 3 over 2 and negative 1 over 2. Moving to 225 degrees. At 225 degrees or 5 pi over 4 radians. The coordinate is negative square root of 2 over 2 and negative square root of 2 over 2 again. Moving to 240 degrees. At 240 degrees or 4 pi over 3 radians. So 4 pi over 3 radians. The coordinate is negative 1 over 2 and negative square root of 3 over 2. Moving to 270 degrees. At 270 degrees or 3 pi over 2 radians, the coordinate is 0 and negative 1. Her cosine is 0 and sine is negative 1. Moving to 300 degrees. At 300 degrees or 5 pi over 3 radians, the coordinate is positive 1 over 2 and negative square root of 3 over 2. Moving to 315 degrees. At 315 degrees or 7 pi over 4 radians, the coordinate is positive square root of 2 over 2 and negative square root of 2 over 2. And last, 330 degrees. At 330 degrees or 11 pi over 6 radians, the coordinate is positive square root of 3 over 2 and 1 over 2.
Done?
So our last topic is identifying the 6 trigonometric functions and their value limits. Trigonometry is built on 6 fundamental functions. So first is sine, represents the y-coordinate on the unit circle. Second, cosine, represent the x-coordinate on the circle. Third, tangent, ratio of sine to cosine. Fourth, cosecant, reciprocal of sine. Fifth, secant, reciprocal of cosine. And last, cotangent, reciprocal of tangent. Domain and range of trigonometric functions. So sin and cos have values between negative 1 and 1. Tan and cot can be any real number but are undefined where cosine or sine is 0. And last, cosecant and secant have absolute values greater than or equal to 1, never between negative 1 and 1.